Okay. Can everybody hear me? How does that sound? Good morning. Let's start 1 minute early. Good morning, everybody. What an amazing turnout. Thank you so much for coming to my talk. My name is James Clark. I work on the composition team in the operating system group in Windows. And I'm delighted, I'm really excited and happy to be here to talk to so many of you today about how you can build new universal Windows apps with our visual layer. Now, before we get started, there's a little bit of housekeeping. You've seen this slide repeatedly. Please get your phone out and barcode scan it and give us some feedback, because we really appreciate the feedback. Before we get going, I want to actually show you a video. And before I show you the video, let's talk for a little minute about beautiful apps. We all want and love beautiful apps, right? Of course. Beautiful apps are the ones that engage us. They're the ones that we keep coming back to. So what are some of the characteristics of beautiful apps? Well, they include more motion, more dynamism and effects. These are sort of given. But really, they need to have a compelling and differentiated design perspective. Now, I want to show you this video that the Office design team put together. It's a video that envisions the future of productivity. And the reason it's interesting is because some of the examples they've created and mocked up around what user experience can look like in the future really inform and motivate our team to move forward. So as you watch it, take a look, really focus on the UX and the UI, not the sort of nice 3D stuff, and let's watch the video. So it's a pretty exciting video, but it's clear that this is really kind of not technology we have today. Everything is in motion, everything is dynamic. And I'm here to tell you how this really exciting opportunity that we have in front of us to really invigorate our UI platform and really power it up with new capabilities is the journey that we're starting on today with Windows 10. Now, the biggest job I've got to do today is to enlist you guys, and this awesome set of folks here really want to get you on board. We want you to kind of kick our tires, help us along the way. It's going to take us a while to get to this sort of level, but we're making some really important steps today, and we really need and value your feedback. So this will be a recurring theme throughout the talk. It's pretty simple, really, 3 sections. I'm going to try and minimize the talking at the beginning, but give you a little bit of context around what the visual layer means to us and what composition in Windows is. We're then going to spend an awful lot of time in Visual Studio looking at code. I've got a lot of demos, so please pray with me that all my demos run. And then we'll finish up looking at our roadmap and just some calls to action for you guys. So what is this thing that we speak of called the visual layer? Well, in system terms, it's really 2 different pieces. It's the engine, it's the composition engine of Windows, and this has traditionally been DWM.exe, and this is the kind of the component in the system that it talks to the graphics hardware, and it binds to every display on your system, and it puts every single pixel on the screen. So whether it's video playback, whether it's user experience coming from an application, or whether it's system Chrome, it all goes through the compositor. Now, the second piece that's important is the API. How do we actually talk to that engine and give it commands? Well, we do that through the composition API. This has traditionally been something that we call direct composition, Win32 API, and it actually powers a lot of the system today. So it powers a lot of the experience in the shell, the start menu. It powers frameworks, and it powers not only the rendering of those frameworks, but also the Chrome, and also the browser stack. Now, I'm still referring to this as Project Spartan here. I haven't quite caught up to Edge, but absolutely the same deal there. And finally, the API is used by third-party apps as well. So that's kind of a real brief overview of what the visual layer is and what the composition engine is. So what were some of the goals that we started out with for Windows? Well, the real guiding light, and the thing that is going to take us multiple releases, but we're really aiming for in the composition team, is to enable the foundational building blocks for next-generation experiences, truly next-generation experiences. And there's really 3 key things we focused on for this release, for Windows 10. The first is a unified composition and rendering engine, and I'll explain why that's important in a sec. The second is there's a set of new capabilities, there's a set of known gaps that we have that we want to start filling. And finally, PowerPoint, thank you. Finally, we want to make this available to the broad set of developers that are passionate about languages like C#. So we need a new programming model. So there's quite a lot here. So let's talk a little bit more about unified composition and rendering. So this is actually what we've delivered in Windows 10. We've delivered a converged compositor. We have a single binary. It runs on all Windows 1 core devices. It runs on the phone. It runs on HoloLens. It runs everywhere. And this is awesome because it means we can deliver a single converged, optimized experience on all of these devices. And we can also enable universal Windows apps to run. The second big investment we've made is in a new rendering engine. And this is an engine that takes the best of Direct 3D and Direct 2D and is highly optimized for dynamic scenes. When you have scenes, you've got a lot of elements and you want them to animate instantly, you need a different way of rendering. And that's what we've built in our new unified core. Now, in terms of new capabilities, there's a set of things we wanted. The first thing we wanted was a lightweight visual layer, a set of objects that are easy to drop down to from a UI framework and program against, and take these and combine them with a new effects pipeline and a new animation system, once again with the goal of supporting highly dynamic scenarios where animation of many objects is something that we essentially designed for up front. Now, from a programming model perspective, clicker please, click. Okay, there we go. From a programming model perspective, I'd like to be introducing this API today. Unfortunately, there are some great people that use tools like metadata diff. I don't know here if Jose's in the room, but it's awesome to see you guys tweeting about, oh, what's all this new Windows UI composition APIs that you guys have shipped. So anyway, we're announcing it officially today, Windows UI composition. This is our new WinRT projection for composition in Windows. It's an iInspectable derived interface, and it's usable from all of the programming languages that you really care about. So first and foremost, our statistics tell us C#. Who here is a C# guy? A lot of hands. So you guys should be very pleased by this. Standard C++. Who's a standard C++ guy? Kenny, where are you? You've got to be here somewhere. And C++ CX as well. Now, these apps that we build using this API need to run everywhere. And as I mentioned, our converged core runs across the breadth of Windows 1 core devices. And it means that apps that use this layer will actually run anywhere. Now, we are in preview. We're not done. This is actually fantastic news because we're iterating much more rapidly than we might have done in the past. And as we push out successive flights, I've gone too far ahead. As we push out successive flights, we will be unlocking new capabilities in the API surface. And that's one of the reasons why we're really keen to engage with you guys and have you give us feedback and help inform what we build. So what does the visual layer mean for a developer in the Windows 8.1 or Windows Phone 8.1 era? Well, it's really, and again, let's see a show of hands. Who here is primarily using XAML as their means of getting UI on the screen? So a good chunk, 50% maybe. So for you fine people, you will know that XAML offers a whole range of capabilities. It has a control model, it has data binding and other features. And for most of the time, you're probably pretty happy using XAML as the way that you get at the system. Now, for certain apps, and there's a great example from the keynote yesterday, the Staff Pad app, guess what? XAML doesn't actually draw music notation. There isn't music notation built in. So for a lot of instances like that, you will need to drop down and use our DirectX layer. Now, there's great news there that I'm sure all aware that we've done a bunch of innovation in DirectX 12, and you can get a lot of low-level control. Now, in terms of composition in this world, composition is beneath the covers. It's not something that you necessarily know you're using, but it's there, and it's the thing that's executing your animations and rendering the content on the screen. And as we move forward to this new world of Windows 10, where you can actually program that, the cost of dropping down becomes much less. Now, there's a lot of power in the DirectX layer, but to get to that power requires quite a lot of code and quite a lot of concepts. And by introducing this intermediate, it's not a new layer in the system, it's just we're offering you programmatic access. A bunch of the things that you need to do more often become much easier, much simpler. So the rest of this session is really going to be focused through walking through the different sections of the API. We're going to start off looking at the lightweight visual layer. We'll then look at the effects system, the animation system, and finally some DirectX interop at the end. And what I'm going to do, rather than talking anymore, is show you a quick demo. And of course, the phone is turned off. There we go, good. So let's switch over to the demo laptop. This guy. Nope. This guy. So what I'm going to show you, this is, we wrote this over the last week or so, a couple of weeks. We had a hackathon on our team as our API started to really come together. We got the whole team working away, and this is one of the apps that we built. It's really just a demo. If you want a real Twitter app, then Brandon Paddock, I don't know if you're here, but Tweetium is my favorite. I love it. This is not Tweetium. This is really just a visualization of Twitter streams. And what we did was we basically made it a XAML app. So we've got the new split view control. We had a little visualization of followers that we thought would be interesting. And so if you're following Win at Win Composition, which is our new team Twitter alias, you may see your picture here. I see a very nice American in the top left-hand corner, which is awesome. So now come back here, and now I'm actually going to visualize this stream. So if we come up to one of these pre-recorded streams, they say don't work with children and animals, and I'm going to add to that Twitter, because some of the stuff I've seen trying to rehearse for this demo has just made my eyes kind of do strange things. So these are actually pre-recorded. I've filtered out things that should not be properly placed in Twitter in the first place. Hopefully fairly sanitary for our consumption. And so this was really it's visualizing the set of tweets that came in at the keynote yesterday. And at the bottom of the screen, we have this histogram. And of course, we get nothing, which is not good. Those demo gods. Let's try this again. Let's try this again and see if this works. Okay, let's pick a different. Let's pick Alex Kipman's session. I recorded different sections of the keynote to see different patterns. So this is essentially going out and replaying Twitter. And for every single tweet that was going out at this portion of the keynote, I'm pulling out the profile images and rendering them on the screen. You may see some interesting stuff here. It's pretty interesting. And then on the top, we're now rendering hashtags. So each of these things are visual objects in our layer. You can see that we're doing animated effects here. And as I switch views, we can do seamless kind of interruption and continuation of the different animations. In the bottom, we have this sort of scrolling panel, this sort of infinite conveyor belt, which is a control we built using our layer. And all of this is now powered by the new Windows UI composition stack. So we're going to take a little look at this as we go forward and build different aspects of it in the talk. Before we do that, let's show it to you running on a phone. So let's switch to this guy right here. And once again, let's see if the demo gods are going to be kind. So this is a Windows 10 for phone build. It's the same app. You can see we've got the same UX there. We again have the pre-recorded Twitter stream. Hopefully it will start to stream in a second. There's a little bit of a delay. You can see that the sort of histogram is starting to light up. And any second now we will get some goodness if we're lucky. Yay. And so exactly the same code running, exactly the same sort of performance, even though this is a humble Windows phone. And I can switch over to my circular render. I've got all of the animated effects. These are all shaders running very efficiently, very smoothly, and giving me an awesome experience. And this runs everywhere. This runs on HoloLens. It will run any Windows 1 core device. There you go. Back to the PowerPoint. Was that cool? A little bit? Just a little bit, maybe. So let's dive in and talk about the API. The class hierarchy that we have is rooted in a type called visual. And visual is essentially at the root of the tree of objects that put content on the screen. We have a set of concrete types that inherit from visual. We have a solid color visual, an image visual, and an effect visual. Those of you with very keen eyes may recognize the fine gentleman that we're picturing here, Kenny Kerr. Kenny has done some awesome content for us, both on Pluralsight and an MSDN magazine. So Kenny, if you're here, thank you so much for being awesome. Keep doing it. Now, our visual hierarchy also, we have an intermediate object that we inherit from that offers collection and containment. And this is really where we have the notion of having a series of children on any given control. And this is not where we're stopping. We have aspirations to go a lot further. We have aspirations to do things like geometry paths, the ability to animate geometries, the ability to do text, particle generation. And as we build these, we want to make sure it's pay for play. So if you're building a very simple visual tree with only images, we shouldn't have objects that are very heavyweight. They should be very lightweight and be very pay for play. So this is what the hierarchy looks like. So what can you actually do with these objects? Well, the first thing is you can rasterize content. You can basically create bitmaps that the compositor can compose. The second thing you can do is positioning, and here we have the ability to apply offsets and parenting to either a parent visual or a window. And we can also do clipping, and the clipping that we're doing here, for those familiar with our existing composition API, direct composition, we've got a new way of clipping that is actually relative to the bounding box of any given object. This is great because this makes it much easier to do clip animations. We can do transformations, so whether it's 2D affine or 3D perspective, and I've got a cool demo of that in a sec. And we've got also the ability to set properties, and properties can be statically set, so I can go up and just set the property on the object, or I can bind them to animations. And we'll talk a lot more about animations in a second. And finally, there's the tree building part. So how does the tree building work? Well, basically the way it works is you have a root visual, and the root visual sits at the bottom of the visual tree, or at the top of the visual tree, and it's the container for everything else that you see. It has a set of children. In the example of the Twitter application, where we had the profile images, we had a background, and we then had a series of visuals. These were bitmaps that we were loading up from URIs. And the way that this works from an object model perspective is the image visual has a composition image associated with it. The composition image is where the bits live, and then the engine can put those bits on the screen. So this is a really simple visual tree. Let's show you how to build that. So we'll hop over to our demo machine now and play with Visual Studio. So here we go. Now I'm going to show you this first demo as a scenario that it will not be as familiar to all of you as to others. And this is a scenario where we don't have the XAML framework loaded. So this is actually a frameworkless app. You'll be familiar with this scenario if you've written games and done games with Direct3D, but probably not from a XAML perspective. The thing that's cool about this is we can actually, by using the composition layer, get a whole bunch of capabilities that would have previously taken a whole bunch of code that we now don't have to write. So I'm just going to run my app, and there's nothing there right now. It's an empty window. And if I just have a look at this particular class, the root kind of object that we have in one of these frameworkless apps inherits from iFrameworkView. And in this implementation of iFrameworkView, the method I'm going to show you that's interesting is setWindow. SetWindow is where we actually capture the core window that we get passed by the activation pipeline. And once we've captured the core window, we're then going to initialize our compositor and build our composition tree. Now, I'm not going to type this in. I'm just going to show it to you. What I've got is I've essentially got a local variable of type compositor. This is a Windows UI composition compositor. I'm just going to new one of those guys up, and I'm then going to use him as a factory to create my other objects. So the first thing I'm going to do is create a target, and this is essentially allowing me to bind my composition tree to the core window. I'm then going to come in and create a container visual, and this is going to act as the root visual that we showed at the bottom or at the top of the tree. And we're just going to assign the root property on our target to be the visual we created. So what we'll do next is we'll actually build the tree itself. So let's come in, and the first thing we're going to do is add a background. So the background we're going to add is going to be a solid color visual. And the solid color visual is pretty simple. It's probably the simplest of all of the primitives that we have. And here we're again using the compositor as a factory that's managing all of our composition resources. We're setting a simple size and a background color. And now all we need to do is add that object to our tree, and we'll see it displayed. Now notice that I'm calling insert at bottom on this children collection. And if we hover over it, you'll see that the children collection is a visual collection. This is a special kind of collection where the order really matters, because the order actually determines the draw order that the objects will appear. Let's just run this, and we should now hopefully see a blue background. And then we'll come in and add some profile pictures. And there we go, nice blue background. So next up, what we have is there's some existing code that's in here that just basically goes and loads profile URIs for Twitter followers for our team alias. And this just basically returns to me an iList of URI. I'm then going to iterate through that list of URIs, calling this method add image visual for follower. Pretty simple stuff. I'm keeping track of some state, so I've set up a size and a position, a current grid position variable, and I just iterate through the loop and increment these to position them. Very simple stuff. Let's go in and look at how we go and add our visuals. So the first thing that we need is we actually need something called a composition image. And this is a pretty cool object because this manages a whole bunch of stuff for us. It manages downloading this image, even from the internet over Windsock or from a local package. And it also manages decoding the image for us. Now, if you're not in a XAML app, if you're doing this in DirectX, you'll know this is actually pretty high amount of code to do this and manage all the resources, worry about device lost, all of these kind of things. This manages everything for us. The next thing that I need is an image visual. The image visual is the object that participates in the visual tree and allows the image to actually rasterize in the compositor. Once again, the compositor is being used as a factory. I'm calling create image visual. It returns an image visual. And I can just simply set the image, the size, and the offset to get that on the screen. So let's run it and see what happens. And this is going to go out and actually download these images for us. It does all of that management. And I forgot one line of code. I actually need to put in my, where is it? Build visual tree. What did I forget to do? Oh, I actually forgot to add it to the tree. That's a bit stupid of me. So let's actually add it to the tree. So this time we're inserting at top rather than inserting at bottom. And hopefully, it's a live demo. There you go. Mistakes and all. Now, a problem that you'll notice is the size of the images looks wrong. And the reason for that is the size I've specified on the image visual doesn't match the actual size of the image. And you know if you've worked with images in XAML that by simply setting a stretch mode, you should be able to correct that. So we have a stretch mode. We can come in and just set the stretch mode very simply. And I'm just going to set it to be uniform to fill. And this will give us the best kind of aspect ratio preservation and fit into the region that I've specified. And once again, if you had to do this in a frameworkless app using DirectX, it would be a lot of code. This is actually pretty awesome. And it's great to see some new followers of our alias as well, live from Twitter. Thank you very much. Awesome. So that was our first demo. Let's switch back now to the PowerPoint and talk about our next topic. Transforms. So transforms are geometric operations that essentially manipulate how assets get onto the screen. And there's a simple form of transforms that we expose that we call individual transform components. And this is for doing simple rotations, simple scale, those kind of operations. And so if you want to just do like a mirror image or that kind of thing, you can do it through the component. We also expose a 4x4 matrix that's fully animatable. And there's a great set of helper methods in the system numerics namespace for kind of setting up the more complex 4x4 matrices. Now, once again, I thought that it would be better to do a demo of this rather than talk a lot. So we'll switch back to our demo laptop. And I'm going to show you another hackathon demo. Now, this hackathon demo was done by a team that really understand 3D. And because of that, they decided to do something a little bit harder than reflecting an image. So what we have here is actually a 3D scene. Each tile in the scene is represented by a composition image. And actually, we're rendering two images, one on top of the other. And you can see there's a very subtle kind of effect of the sort of glowing happening. And that's done using a simple animation. Now, we also have a perspective camera. And I can actually change where that camera is looking. And you can kind of see here from the performance we're getting kind of what our engine is capable of. Our engine is not a game engine, it's a compositor. It's not really designed for games, but you kind of get the idea that from a scalability perspective, we've made some good strides. Now, if I come up to this door, there's actually another room, believe it or not. And with a very clever depth sorting algorithm, we're able to position these objects and partition them into two different worlds. So once again, this is pretty cool. This is what you can do with our sort of matrix transform and cameras if you get 3D and you get 3D math. It's pretty cool stuff. What do you think? Okay, so let's move on. Next topic, and we're going through this fast. So next up, I want to talk about how does all of this relate to XAML? I'm a XAML guy. Please explain everything you just showed me and how it relates to XAML. Well, for those of you that are XAML people, you'll be very familiar with the element tree, and you'll be familiar with grids and how we nest things. Now, who here, excuse me, who here attempted to use the web view control back in Windows 8? Anyone try and do that? You guys may have got a little bit frustrated with how the web view worked in Windows 8 because we had a really fairly major problem with how the web view got composed. We had a major issue that we call in the trade an airspace issue. This is where you couldn't actually get the Z ordering of the web view versus other content correct. Now, to solve that was actually very hard. We had to completely rip out how XAML rendered, believe it or not, and we had to make the XAML engine aware of the composition stack underneath it. And so back in the old world of sort of Windows 8.1, when we fixed this problem, what you would get is a web view being backed by a visual in the composition tree. Now, for those of you, anyone here do game development at all? Anyone here do sort of swap chain panel style programming? Maybe a couple. Once again, if you wanted to do DirectX integration, we did this using the composition tree, and we had this object called swap chain panel. Once again, that object is backed under the covers by visuals from our visual layer. Now, the thing that we're doing today, and the new code that you can write as of today, essentially allows any element in the XAML tree to be retrieved as a visual. What this means is all of the new capabilities, the effects and animations that we're exposing, can essentially be applied to any element in the XAML tree. Now, I talked about our roadmap and how we really want to make a much more dynamic system in the future. Our vision for this is that actually every single object in the framework layer is backed by a composition object. And this is where we really realize the dream of being able to have anything instantly animatable at any moment in time. So why do you want to do this? Well, it's a great question. It's a very great question indeed. And to be honest with you, 80% of the time, you probably won't need to. XAML will probably be a great choice. XAML has a bunch of rich capabilities that will serve your needs. However, there are some key scenarios that do matter. The first is if you want to use some of our new capabilities and do things like effects and some of the expression-based animations that I'll show you a little bit later, that's probably the reason number one. Reason number two is scale. If you want to build really highly sort of complex scenes, and you don't want to carry the weight of having to build like a UI element tree behind that, but instead you just want to build more of a graphics tree, that would be another great reason. The third reason is input. Now, I haven't talked much about input, but input is critical. So to get some of these smooth and fluid experiences that are driven by input, like sticky headers, if you've ever used one of those kinds of list views that has like a group header, and the group header animates and then like freezes as it gets to the top of the screen, these are scenarios that really benefit from this lower level of integration that we offer. And finally, if you're a control developer, and if you want to build controls that kind of have animation and manipulation at their heart, so a little bit like the panel that I had that was showing us the histogram of tweets, that was intrinsically something that was animating, and hence probably quite a good candidate to drop down and use from our layer. This slide is not one I'm going to dwell on. This slide tells you how to get at the composition layer in a XAML app. If you're interested in actually trying this, I would highly recommend download this deck, and there's a whole bunch of hidden slides with code samples that you can actually go grab and see and paste directly into your app. There is a special thing you need to do right now, and that is essentially enabling the composition layer support in your XAML app. It's not much code. You paste it in, you'll be good to go. It's in the deck, so I'm not going to show it right now. What I am going to show right now is how this works. So let's jump back to our demo laptop once more. Wrong demo laptop. This is the right one. And let's come down to our XAML example. And what I'm going to do is switch over, and I'm just going to run this application and show you what I've got. So this is where I started to put in the Chrome around the Twitter app that we were building. And what you'll see is there's a very large red region. I've intentionally colored that red to be able to illustrate to you where we're kind of joining the trees together. So let's look in the XAML, and you'll see what I'm basically doing is I have this grid. It's empty. There's nothing in it. And I've colored the background red. And I've called it followers host. So what I'm going to do is just copy that and switch over and look at the code. Now, we actually need to initialize composition in the XAML app, but we do it a little bit differently than in the core window case. The way that we do it is actually as follows. I'm going to use a new method, and there's a thing that there's a static helper class that we now have called element composition preview, and that is in the windows.ui.xaml.hosting namespace. And on this method, on this static helper is a single method called getContainerVisual. And getContainerVisual takes a single argument that is a UI element from the tree. So I'm going to just paste in that argument. And now what I'm going to do is assign my root visual to be that guy. And what I'm going to do is actually cast it to be a container visual because that is the type of our root visual, and that's the type that allows me to add children. Just fix the typo. Now, those of you with sort of a key attention to detail will probably realize this app won't run as is. The reason it won't run is we were using this compositor object earlier on as a factory to make new objects. Where's my compositor coming from? Great question. Well, the answer is it's actually coming from the visual that I got back from XAML. On that visual, I actually have a compositor property. Now, where's the compositor property coming from, you may ask? Let's go and have a look at that. So let's come up to container visual. If I hit F12, you'll see that container visual, as expected, inherits from visual. And if I select visual and hit F12, you'll see that visual actually inherits from a thing called composition object. And if we have a look at that guy, composition object actually exposes a compositor as a property. Now, the reason it can do that is because we're using the compositor as the factory to create all of the objects. And so the factory is able to just put a reference to itself in every object it creates. It allows us to do things like manage lifetime, and it also allows you the convenience of being able to get at the compositor from anywhere. So let's hop back and actually make this run. So we need to now put our build visual tree code in. This is exactly the code we just made that's making image visuals and essentially putting them in the tree. We're going to run this, and with luck, we will see some more faces smiling at us. Wonderful. And more followers. Yay, awesome. Woohoo! Lots more followers. So this is kind of composition working together with XAML. Let us hop back to PowerPoint. What's next? What's next? Effects. Effects are next. So effects are not new to Windows, and those, I'm sure there are those in the room that have worked with WPF. I'm sure there are those in the room that are big fans of Silverlight and the kind of shaders and stuff that Silverlight did. The problem that we've had in the past with effects is they haven't really been implemented with a performance-first kind of mindset. And this is really now critical for us to do, and we have to be very careful what effects we expose. The reason for that is we run everywhere now. We run on OneCore, we run on HoloLens, we run on like Raspberry Pi, a whole different range of devices, and we have to make sure that our composition effects are highly tuned and highly optimized to run really well across the breadth of devices. So that's really the focus, and has lent us to a sort of cautious approach. We don't want to expose the kitchen sink and discover, oh dear, it doesn't run very well everywhere. We want to be very mindful of exactly what scenarios we want to enable and do them in a very optimized way, one at a time. Now, there's some cool stuff you can do with our effects architecture. You can customize effects very easily with properties. You can animate their properties. So that kind of circular mask effect, we're actually animating properties. Ultimately, those are values in a shader program, so they're highly performant, highly GPU accelerated. And we've also gone with a consistent way of describing effects. And this is, again, something we're trying to unify in Windows. We've got kind of different effects in different places, and we're trying to bring all of those together. So the way that we describe effects is something that we're now making consistent. We're using an effects description that we share with Win2D, and in the future, we'll be sharing with the effects pipeline that the video stack uses. So the set of effects we expose today, and this list is absolutely not finished, and we'll be building way more over time. But the list as it stands today is we have a whole bunch of composite modes, which is a way of doing alpha blending between different entities. We have blend modes, color source, saturation, and also a 2D affine transform effect. This can be used for things that we call UV transform effects. So for those of you with Windows phones, you remember that effect on the lock screen where the photos kind of are inside the tiles and the whole thing moves very nicely? That's using this notion of like a UV coordinate effect that we support right here. Once again, let's let the code talk rather than me and switch back to the demo system and show you how we can add this circular mask effect. Now, I'm not going to go into the detail of adding the animation because there's actually a world that you need to learn about for animation. There's an awesome talk tomorrow that Nick Wagoner and Jeff Stahl, who's actually the architect of this API, I really highly recommend you guys check that out. And they've got a really awesome demo that I'm not going to show you today. That's going to be saved up for tomorrow if you go and see that talk. Anyway, with that said, I'm going to switch over and do this simple effect operation. So where are we? Composition effects, wonderful. So let's run the app and show you what it looks like. So right now, this is going to just be the regular old square, rectangular, oblong, however you want to define it. Fairly boring geometry there. We want to replace it with a mask instead. So what I'm going to do is come in and I'm going to take the image visual I added earlier, and I'm actually going to delete it, blow it away. I've still got my composition image, and this is where I went and got the bits from the internet, downloaded them and decoded them. Great, wonderful, I can reuse that part. But what I need now is I need a mask. And what I'm doing here, let's just line break this, is I'm using an asset that I have in my package. So if we come down and have a look in the assets, we will see circular alpha mask. If we hover over it, we may even get a preview. And this is where my alpha information is coming from that is introducing the circular geometry. So that's all well and good. So what I need next is I need an effect description. And this is the entity that I mentioned that we're converging with Win2D. Win2D, if you haven't heard of Win2D, there was a great talk yesterday. I'd highly recommend you go watch it. Win2D is a way of programming DirectX from managed code. It's very cool stuff. I've actually added Win2D to my project here. So if I go and manage my NuGet references, I've actually added Win2D, and I've done that purely to get at the effect descriptions that I need for this one. The effect in question I'm doing is a composite effect. I'm not adding any rendering code from Win2D. So the implementation of this composite effect is implemented in the compositor. It's implemented highly efficiently. It'll run on all of our platforms with great performance. So the only thing that's coming from Win2D here is the description, just to be clear. So next what I need to do is I need to make a factory. So this is where we start to compile the effect and we start to actually have shaders lighting up, pixel shaders, vertex shaders, etc. So I'm creating an effect factory. I'm calling that on the compositor once again. It's a composition object that we manage. And I'm passing into that the effect description that I created above. So just passing that in simply. And then the final step I need is I need my instance of the effect. And this is where we would actually give the parameters to the shader program. We'd actually sort of give it the textures it needs under the covers. And it's where we would apply animations and those kinds of things. What I've done in my description is I've added these source parameters. And this is how I bind my composition images into the effect itself. I've got one called image, I've one called mask image. And what I'm doing on my effect instance is now passing in my profile image that I got before and my mask image that I loaded from my package and setting those up. So the shader program now knows how to draw this for each element in the tree that I'm adding. So all that I now need to do is the final step of adding an effect visual. And the effect visual, similar to the image visual, again, it inherits in visual. It's the guy that goes in the tree. And it's where the size and offset is applied. And it's also where the effect is applied right there. So if we run this, with any luck, we will see some nice circular masks. Boom, lovely. So the next step is, if you kind of want to see the next level of customization for this, I do highly recommend tomorrow's talk. I'm going to show you one more thing. I'm going to show you some animation features. And then we will, how are we doing for time? Not too bad. So let's switch back to the PowerPoint and show you some animation features next. Cool. So I think everyone here is probably familiar with animation. It's a very simple notion of changing a value of something over time. And in our animation system, we support pretty much all properties on the composition objects that we expose as being animatable. So whether it's position, size, or transform, and whichever flavor of transform you pick. I didn't mention earlier the orientation transform. The orientation transform is if you're trying to do animations in 3D space. And we have to use a thing called a quaternion to do that correctly. All of those things are animatable. We can also apply animations to the effects, as I mentioned. So this is where you start to have shaders and you start to want to be able to animate them. We need a system that is capable of doing that. Now, it's worth mentioning that all of the animations that we have are executing in the compositor. That means that they're independent of anything the app is doing. The demo that's really cool is you can actually put a breakpoint in your code and stop in a debugger and actually see the animations carry on playing. The reason for having independent animations is not for that particular scenario, but for when a scenario like if you're doing a lot of work on the UI thread and the UI thread is blocked, we don't want the animations to glitch. We also have great interruptibility of our animations. So if you have, and you may have noticed this in the Twitter wall where we had things cascading down and we then changed the animation and they essentially drifted to that new place. Because the compositor knows exactly where any object is on the screen at any moment, as soon as you apply a new animation, we can actually automatically transition from the old one to the new one. This gives a really pleasing effect and really kind of makes the system much more dynamic. We have also focused a lot, again, on performance, and this is sort of a recurring topic that you're probably getting a little bit bored of, but it's good news. It's really good news because it means the animations scale really well. The way that we schedule these, it's very easy to take one animation definition and apply it to many, many objects. You don't have to go and build up a complex object graph for each single object you want to animate. This is a really big win. And finally, there's two modes of animation, and this is most easily thought of as an explicit animation is something I create and apply, and that's pretty understandable. I'm creating it, I'm applying it. The other kind of animation that we're intending to support, we're not supporting that in the build that you have from build today, but we will be adding it at a future date, and we'd love to hear feedback on whether, what your thoughts are, is a kind called implicit animations. And this is where, when you have a property value like a position, you can essentially configure it that whenever that position changes, whenever I change the position, it'll automatically animate between them. This kind of saves a lot of code and is kind of a really desirable feature for just simplifying building up complex animated scenes. So let's go through this pretty quickly. There's two kinds of animation we support. Firstly, keyframes. I'm not going to dwell on this. It's pretty straightforward. We support different easing functions, and we support different value types that we can animate. The more interesting kind of animation that we support are expression animations, and this is where you want to relate an animation on one object to an animation on another object. So we talked a little bit earlier about sticky headers. Another example of this is parallax or scrolling indicators. If you're trying to build these kind of custom animations where objects are related to each other, you can use expression animations. Now, rather than trying to explain them, I think it would once again be better to demonstrate it. So let's switch back to the demo laptop and add some animations. So once again, we'll go from the starting point. And here I just have a static set of objects that are not moving. I want to make them move. And the way that I want to make them move is I essentially want to have like a deck of cards. If you throw a deck of cards on a table, they kind of slide out from each other. And as they sort of slide out, one gets to a position and then another one slides out from underneath it. This is something that could be quite challenging to build without expressions. Thankfully, expressions makes it easy for us. So let's jump over and set this up. So what I'm actually going to do is create two animations. The first one is going to animate the first item in the collection, and then each subsequent animation is going to be based on the previous object. And I'm going to use expressions to make that relationship there. So let's add our first animation. This is a vector-3 keyframe animation. The reason that this is a vector-3 keyframe animation is because I'm animating the offset property. This is essentially the position of where the element is. An offset is a vector-3. One thing to note is that the way that I define my keyframes is actually using a percentage-based scheme. This is pretty nice because it means you can define all of your keyframes and then apply the same animation with a different duration to different objects without having to create a whole bunch of new animations. This is pretty cool stuff. I'm specifying a duration here, and let's just apply that first animation onto our object. So I'm going to say connect animation, and the name of the property is offset, and the animation is called first animation, and there we go. Now, if I were to just run that code, it would actually not animate. The reason it would not animate is very simple. Connect animation returns something called a composition property animator. This object has a number of functions. One is it allows me to control the animation, so I can start the animation, stop the animation. It's also a way that I can get notifications back. Now, those of you that are familiar with direct composition, the Win32 API, know that's a one-way API. You can never get notified when something like an animation completes. We fixed that in our new WinRT layer. These animations all support an event model. I'm not going to show it to you, but it's there, just for when you need it. Trust me, trust me. Okay, let's run it and see what happens. So I've only created a single animation now, and I've applied it to each object in the collection. So surprise, surprise, they all do exactly the same thing. Not very interesting. So let's go in and do part 2 of this. So what I'm going to do is I'm going to first of all create a variable to keep track of the previous visual. So as we step through the collection, I always know the current guy I'm on and the one before, the previous. And now let's come in and create the second animation. So here we're going to, again, create a vector3 keyframe animation. And this time we're actually using something called an expression keyframe. And the expression keyframe actually allows me to pass in variables to the animation. So here I've got two different variables. I've got one called previous and one called final. And as I apply that animation and bind it to an object, I essentially set up what those variables are sourced from. Let's do that next. So I'm just going to do a simple if statement here. And I've done something bad. That's not good. Okay. I've replaced the wrong thing. There we go. Don't need that. Great. So hopefully this will now compile. So basically what I'm doing here is for the first iteration of the loop where I don't have a previous visual, I'm doing exactly what I did before. I'm just connecting the first animation up. For each subsequent step in the loop, what I'm doing is I'm essentially doing this thing called set reference parameter, and that allows me to basically fill in the variables for this animation instance. So what was referred to as previous in my expression, and I'm going to use previous.offset, is filled in. And then my final value is also filled in with the current grid position. And so let's just run it. And I've slowed this down on purpose just so that you can see what's happening. And basically what you can see is each object is picking up from where the one before it left off. There you go. Now, once again, Jeff and Nick tomorrow will be showing much more of the power of what you can do with expressions. And you can use expressions against effects. You can use expressions to build some really cool scenarios. Highly recommend you check that out. Is that cool? A little bit? Awesome. OK, so into our final section, DirectX Interop. We basically support DirectX Interop on image visuals. So if you want to do things like bring in Direct3D or Direct2D content or even Win2D content into your app, you can use these native interfaces to get to that capability. Scenarios are things like multi-layered game HUD if you're building a game and you want to have a head-up display, or you want to do some advanced video playback. Maybe you want to have video playback with Alpha Channel or something like that. These are all reasons why you can use Interop. It does require a little bit of native code to hook up, but the power that you get from this is once you bind the D3D or the D2D content into your tree, you can then continue to use animations and effects from the composition layer on those objects. One of the things from the future that we're looking at is how do we do native support for Win2D. I will show you a demo of that today, so if you want to actually kind of combine Win2D immediate mode rendering with composition, you can. And let's do another demo. Gosh, lots of demos. Switch back to the demo machine. So I'm going to show you two quick demos. Did that switch? Yes. So the first one I'm going to show is, it's kind of Hello World for Direct3D. So this is a bit of an in-joke in Microsoft. Anytime we bring up some new platform that has a 3D renderer in it, it usually has this dolphin animation. So it's like we got to the dolphin stage. Well, here we are. We got to the dolphin stage with composition. And what you'll notice is this is kind of rendering at 60 frames a second using Direct3D code, but it's also animating. And that's because I've applied a composition animation to the object. I'm not going to show the code for this. If you're interested, I'm guessing that fewer people are doing Direct3D Interop. If you're interested, you can get this from our NuGet repository, and I will be pushing details on that at the end. Let's just show the final demo, which is Win2D. And Win2D, once again, it's a way of getting to Direct2D from C# code. So you can build some pretty nice animations. I've got an example here. This is a XAML button. You can see I'm highlighting the button, and it says rub two sticks together. What happens when you rub two sticks together? Catches fire. So this is basically a little baby swap chain, and I'm rendering into it with C# code, and this is using actually one of the Win2D samples to do procedural. It's a particle system that's using procedural techniques to generate this fire effect. You can see if you look really closely that we're doing great alpha compositing on top of the actual text that was in the button. And this really highlights the power of the composition layer that you now have access to. So once again, I'm not going to go into the code because I want to talk to you about our roadmap next. So let's kind of close out the talk just talking about what's coming when. So the first thing is we really want to hear from you guys. We really, really are listening very, very attentively to feedback. And we really encourage you to email us. We have a team email account, wincomp@microsoft.com. If you've got feedback, if there's projects that you're working on that you need features for, if there's feedback you want to give us, like why didn't you think of this or we like this, please send us feedback. If you want to know what we're up to, and when you get a new flight of Windows, you don't want to go and look at metadata diffs, you actually want to hear it from us, then follow us on Twitter and we will be publishing details. We'll also be publishing a bunch of the samples I've shown. We're going to be rolling those out into a NuGet repo over the course of the next days and weeks, so do follow us. In terms of what you're going to get, everything I've shown you today, you can do today. So you can basically go in and do all of the work with the visual tree, the animations, the effects, and the XAML interop, and we do want your feedback on these things. There is a restriction that we have at the time of WinRTM, which is these APIs will be in the box, but we will not be able to accept app submissions that call these APIs at the time of RTM. Now, that may sound negative. The good news is, with Windows as a service, we can actually pick the moment that we're ready to freeze the API. And one of the reasons we don't want to do that right at RTM is we're not done. We're not finished. We're still working on this. And we want to make sure we really get it right such that we then don't have to go and do a whole bunch of breaking changes. Our target is, by the end of this FY, our API service will be fully kind of permitted to be called from all apps. And you'll be able to use it and take advantage of it from there. Now, one of the benefits of this is you have a great opportunity to give us feedback, and you have a great opportunity to sort of give us feedback into this cloud bubble. What are the things that you think would be most impactful? What are the pain points in your applications that's making them less competitive, that if you had this feature would really help? You know, is it path animations? Is it more effects? What are the kinds of things you want? So do give us feedback. Do tell us what you would like to see us do and what would be most impactful for your business. A couple of talks to point you to. The first, I've pitched to you a lot. I will pitch it one more time. It'll go into much more detail on motion and effects. And it's Nick Wagner and Jeff Stahl. It's coming up tomorrow, a little bit early, but don't worry, the coffee will be very strong. The second one I referred to already from yesterday. This is talking about the Win2D API. So if you're interested in the particle fire and you want to learn more about that, that's a great talk. And the final one here is talking about API contracts. And this is interesting because it allows you to do sort of feature detection on what APIs are available. And it's a great talk that Brent Recht is doing. So the rest of the details are self-evident. We will be posting sample code on NuGet. Follow us on Twitter, and we'll be posting links to that. Please do evaluate the session. Tell me what was good and bad. It's always super helpful. And with that, have a fantastic build. If you've got questions, come up or see me downstairs. Thank you very much.